In the AWS Developers Podcast, we're talking about coding assistance for developers. Good morning, good afternoon. Thank you for listening to the AWS Developers Podcast. We are available in all good podcast applications, YouTube, Deezer, Spotify, Apple Music, you name it. If you find the AWS Developers Podcast in your application, then it's probably a good podcast application. Today we are recording from Las Vegas, re:Invent. re:Invent is the AWS Customer Conference, and I have the pleasure to welcome Vitor Monteiro, your head of solution engineering for Europe, Middle East, and Africa at Poolside.ai. Tell me, what is Poolside?
Hi. First of all, thanks for the invite. So lovely to be here in the podcast and in Vegas. So what is Poolside? Poolside was created to achieve AGI for software development. And we know that's a big bar. Mm-hmm. And I think that word is thrown around quite easily. But I joined because I truly believe that mission. So if we look at the world today, AI has come and we adopted AI at a pace that we haven't adopted anything.
Anything in the last 10 years, 20 years.
And it's phenomenal. But we're kind of stuck, I think. We're stuck in kind of the code assistant land. Copilot kind of led with a very solid product from the get-go. And what we see now is that developers expect way more. It's phenomenal. 2 years ago, it would be, how can this possibly work? And now it's like...
It's not enough.
It's not enough, which is curious, but very typical of developers as well, right? We always want more and we always want better and we're always trying to find the next edge.
And they had some doubts as well. I had some doubts at the very beginning saying, it's like code suggestions on steroids, but no more than that. But now we see the potential of the technology.
Oh, completely. And I think we as an industry evolved a lot, but we're still kind of in code assistant land. You start seeing some agentic behaviors here and there, but we feel like there is a massive gap between being helpful and being someone like you sitting next to me, actually helping me proactively. People usually say that's agentic. So we think that Poolside is building the necessary foundations and AI capabilities to bridge that gap and go beyond. And then we can talk about AGI, but not just to be the thing you chat with or that code completes some code, but something that you feel someone or something in this case, it's hard to describe, but that is really helpful, like a junior developer or in the future to be a development team on itself.
So how does it work? What are you doing? You mentioned Copilot. What is different?
Okay, so I think is still on the aspect of describing what is Poolside, and I'll go on what's different. To kind of put Poolside in the context of the industry, we see Poolside as a one-of-one company in the sense that there are about 10 companies, 15 companies that have the necessary compute to produce frontier models. So obviously OpenAI, Google, AWS, Poolside. So that already puts us in a very restricted group. Then we are building everything from the ground up. So we're different from companies that we call AI consumers, Copilot being one of them, for example, where they plug in a model and they take care of the user experience. We're building everything. So we're building data pipelines, all the training software is very custom. We don't take anything pretty much out of the box because we don't want to be limited by what open source can give us at this point.
So you're collecting the data, writing the training algorithm, and running your own training.
Everything. There's very little, and not because we don't want to. It's smart to use the components. It's smart to use components that can be helpful. But while building foundation models, we decided that we needed to kind of own our destiny in terms of software decisions and software choices. So the first year of Poolside was very much building the foundation that will allow us to get to our goals.
But it allows you as well to really focus on the one population you're targeting, which is the developer. You're not trying to create a generic purpose model.
Exactly.
It's a model to help developer.
And just to finish kind of the point of the group, so then if you kind of filter, okay, now within the companies that are building everything from scratch, There's only one focus on software development. So if you start applying filters to that, Poolside is trying to build AGI for software development, and our focus is software development. So why are we different? We're building foundation models for software development.
That's different.
that's very different, and we think that will allow us to over time bring the intelligence and the model capability to a place where we really can bridge that gap of the code assistant land, which we're stuck in for the last few years, and that's one of the key aspects of it. The other aspect of it is that if we're looking at scaling laws and we look like to get more capability out of the models, we talked about the compute, right? Poolside has the necessary compute. But what is the other limiting factor that if we look at traditional scaling laws that we hit?
Storage, compute.
So assuming that we in those 10, 15 group of companies have the necessary compute, the bottleneck that a lot of companies will hit is the data, useful code data. There's not a lot of it, and we're not generating enough of it. So and this is quite interesting, like if you go out there and find what data can we use, and we go to GitLab.com, GitHub.com, you go to all those data sources and you start looking at the code to train the data, you'll suddenly find that probably only 10% of the data is useful, because you have to filter down to the essential, valid, non-duplicated code that we can use to train the LLMs.
Which is recent, well-maintained.
Yeah, likely filtered by English coding standards, etc. Duplication is massive, right? Go to GitHub,
all the forks.
the forks. So even when you find a very good repo and it has 1,000 forks, right, and then all the branches, etc., you're only going to take one copy of that, and that's very important. I've been told that it's very important not to have duplicated data in the training set. So one very unique thing about Poolside, which is a technique that ISO, our co-founder and CTO, a quick off-topic on ISO. ISO was trying to do software AI for code when it was not popular and on everyone's mind. So he started a company in 2016 called Sourced that was trying to solve this challenge.
2016, you said that's 1 year before the foundational paper from Google that allows large language model to exist today. So
to have someone that has genuinely been trying to crack this problem before it was in everyone's mind is really unique, and ISO is definitely someone also worth speaking to. But basically, how do we get more quality code data? We need that. Even if you have the compute, you get to a point where we know that models thrive on good quality data. So ISO and team develop a technique that allows us basically to generate pretty much unlimited high quality code data.
To generate
synthetic data. Synthetic data is not a new concept in AI. For code, I think I
think it's new. It's
the
first
for
time
code, I've actually searched for it to try and see how much of a unique proposition, and I think it is, at least what's in the public domain. So this technique is super interesting, and I could go on for hours. So interrupt me if I'm going too deep on this technique. It's called reinforcement learning from code execution feedback.
The reinforcement learning, again, it's not new. It's something that we do like for Alexa since many years, but in the context of
code execution feedback.
How it works.
And this is amazing for me. I'm an engineer, so just the engineering that goes behind this is what fascinates me a lot. So let's imagine that instead of I will eventually explain how it works, but from an engineering standpoint, imagine that there is a program at Poolside that scans the internet for high quality code repositories. All of what I'm saying after this happens automatically. So we're looking, and we found a repo on GitHub.
1,000 stars and hundreds of forks.
We do a lot of validation on that. So one of the most important things is that we can deterministically validate that any changes to that repository are right or wrong. And this is the key point of...
like in the commit history?
So we need unit tests at the very least. There's other validations that you can apply on top. And this is a bit a pattern where you can plug in additional validations. And I'll get that in a second. let's imagine that the program founds this repository and says, okay, this qualifies our selection criteria. Take the repository out, download it into our reinforcement learning from code execution feedback farm, and now go through that repository history, and for all the commits that make sense, that actually
add some value,
and are kind of complete in a sense that they're not kind of intermediate commits, etc. Good repositories usually have good hygiene in that. Let's for all those commits on that repository, hide the commit change and describe what the change is in natural language. That's the prompt. Give that to our models and let our model come up with 50 solutions.
50 code generation that are equivalent from the description to the one you observe in the commit.
Now, from those 50, about 5 or 6 things can happen. It can pass all the tests, any additional security checks, vulnerability checks, they pass. It's the perfect solution. We know that works.
Leveraging the unit tests from the project to test the code that has been generated.
And I'll stop here to say how important this is, because the way to think about this is that we are teaching our models how to code, and we're not teaching them about code. Because the only thing that we can extract from the web data is the output code. So you have this solution or this repo at this point in time. There's no oracle of truth to say if that's right or wrong, or is that actually working, or was it working at that point in time. So when we run these 50 solutions, we have the ask, the solution, and the result. All of this is new training data. So from those 50 examples, 10 might pass all the tests. Of those 10, 3 will be very high quality based on other analysis. 10 of them might only pass 10 tests. That's great, because we know all of that, not compiling if it's a compilable language or a runtime error in a JavaScript project, all of that is high value data, because we know for sure that in that particular case is going to generate a runtime error that is going to pass all the tests.
And so you have a ranking system to feed the reinforcement loop, saying, okay, this is
part
good
of the
code,
process.
plus 10. This is not compiling, minus 10.
Part of the process. It's a simple way to think about it, and I think that helps. It's how I think about it, positive reinforcement or negative reinforcement based on that. So now, imagine that obviously this is a computer working on this. So while we've been speaking here, it has gone through many commits, right? Obviously the model, you have to prompt the model, the 50 solutions will take some time. What if I told you that farm now has beyond 200,000 repositories?
Wow.
And this is all automatic. So when you make a change to the factory, it's almost like an assembly factory. You make a change. Okay, so now for qualification or for grading the solution, we add vulnerability scanning. To grade the solution, you can plug in anything you want after that.
So you're plugging other layers of verification on top of the the code generation, unit tests, runtime tests, and then we can add many more.
And that's the beauty of the of this framework, because you can extend on it and the output and continue enriching the output and increasing the output. A lot of people, when we present this, start thinking in their heads how they would engineer this and say, okay, but what happens when all the solutions are perfect? And that's a great problem to have. Other than distinguishing which ones are better through any mechanisms available today in the industry, you can make the problem harder. Right? So if I'm giving you a commit and the commit is a function or is a method or is fixing a bug that's one line fix, and our models get to the point where this is too easy, right? I'm giving you 20 solutions and they're pretty much almost all the same and close to the best one. You can increase the scope. You can increase the difficulty. You can go from commit to a pull request. And then when the model has made the gap in intelligence, you could go from a pull request to kind of describing the project, right? So imagine it getting to a point where for that repo, you're not asking for a pull request, but you're asking for the project, describing what the project does. So this is the interesting part, is because the more our models become capable, the more we can increase the difficulty of this framework, continuing to generate more code. So we expect our next state-of-the-art models to have about 1.5 trillion tokens of this synthetic data, and broadly, this is always hard to calculate, depends on which data components you filter on, etc. That's probably around 50% of all the usable code data around the world, which we estimate around 3 trillion tokens.
Wow.
So
how much time it takes to produce such a new model? Compute time, I mean, not the research.
So I can't precise. Another thing we've worked a lot is in kind of doing iteratively experiments and parallel experiments in different combinations of model architecture. So we have founding principles. We have an amazing team of research and development, and we now have the necessary compute to do a lot of small experiments. And then after a while, we do a few selections. We further those experiments, and then we decide on one model that we're very convinced, because you can't just do, at least that's not how we do it. In this industry, it's hard to say you can't just do, you can do whatever you want. But if you think about 100 small experiments that we do small scale training on, if we select 10 of those, if there's one that's better, we can't necessarily say that's going to be the better if you train a very large model. So you have to see the progression of that model over the training and over the impact of the data. So probably from those 100, we'll take 10. And then from 10, we'll take 5. And then we'll find patterns of scaling laws and say, okay, this is the model we're going to train, because this is what we're seeing with increased training and increased data.
And you have to find a model which is good in many different functional use cases, not something very specific. So it must be good across the line.
Exactly. Fine-tuning does play a big part on that, on how the model communicates, how the model responds, etc. But yeah, for the base intelligence, that's how we do it. We're going to, I don't want to release code names of models just now, but in 2025, we hope to come out with a state-of-the-art model for software development based on all of this we just spoke about, where the synthetic data generated from RL-Ceph will take a big focus in the pre-training, and we think that will allow us to bridge the gap of capabilities, and that's what we're betting on.
There is another difference with the other coding assistants that I know. It's that you're not a SaaS, you're not a software as a service provider. So your customer can download and install the model on their infrastructure in the cloud. Why?
That's a very good question.
There is one aspect, of course, I can think immediately. It's data privacy. I have the model in my infrastructure, and I only share data with inside the security of my VPC.
This is very interesting. And before we get into that, I think one thing I didn't explain very well is, what does Poolside look like today as a product, right?
The end user experience. Oh, we can come to that as well.
Yeah. And this just takes 1 minute. It's basically, if I am a developer and my enterprise has installed Poolside in their own infrastructure in AWS, I will have it. A code assistant which brings two of our models, Code Completion and Chat, into your IDE. That's Visual Studio Code, all the JetBrains IDEs, and a web assistant on the browser. And we're pretty much API first, so everything we've built, all these 4 things I've named,
are consuming the API. That your customer can consume as well, so they can create their own tools as well.
And we think that's essential, especially, this is my own view on things, but most of the consumption long term, especially when agents start communicating with each other and being more agentic, the API is going to be your biggest vehicle.
You're at AWS. You're talking about.
I'm a big fan of
is API. So in that aspect, it's not really different than from the others. So it's a plugin to install inside Visual Studio Code for the developer, and then you have 2 experiences: a chat where the developer can ask questions or select code and ask questions about the code, and code completion in suggestions. It's more than code completion, code suggestions inside the editor.
Yeah, and the API, I think, is a big differentiator. Then, so Poolside gives you. We want to give developers a vertical product that goes from the model that you could query directly, but also the user experience, and we're very focused on that. But your question was, we're a bit different in the sense that you can download and install
the model
on your enterprise.
on your infrastructure.
That's more than a can. That was
They
one
must.
of yeah, they must. That was kind of a pillar of where we saw the gaps in the industry. Our CEO and co-founder is Jason Warner. He incubated GitHub Copilot at GitHub and did things like GitHub Actions. And he knows very well like the domain of selling to developers and selling to enterprises. And what we've seen is that like because this was adopted at such a pace, AI, right? I know so many companies that would never use a SaaS service like this, especially when you're sending code outside your network, but didn't have any choice because you just told me that you just started using Code Assistant X, and now I feel like that backwards company that I'm not using it. So I'll just sign off all the papers and all the security risks, and I got it. I've done my job as a CIO or a CTO. And we see that a lot of companies made that choice because there was no alternative. So we do plan on playing on the providing Poolside to every developer, and that implies obviously a SaaS product long term. But currently, the value we want to bring to customers is customers that definitely want two things. They want to make sure that the model goes to the data and the data doesn't go to the model. So if you're using Poolside, it's because you've set it up in an AWS VPC and you have total control of the data circulating. Any context going, any future integrations going, any data going to the model, it is in your secure network.
It requires quite heavy infrastructure with GPU, or what type of machines do we need?
So it really depends. It really depends on your use cases. And there's
a
lot
of developers interacting with the model, obviously.
And that will change a lot. We're obviously at reInvent, and we're going to make some announcements regarding Bedrock as well, which will in time not require you to get all these expensive instances up front.
So that's a good point. I stop you there. You're going to make an announcement at reInvent, but technically we are recording this before the announcement. Yeah. If you're listening to this podcast, it's after reInvent. Yeah. So we cannot tell you exactly what, because everything can change until the last minute in this type of deals. But just look in the notes of the podcast. I will link you the blogs and the press article related to that. So you will find the things that we cannot talk about right now.
Thank you. Yeah, but definitely check those links because that's going to be short term are kind of two ways to use Poolside. Either you deploy everything within your VPC, or basically you the model aspect, the fine tuning, the inference will work on Bedrock, and that takes us to the other thing. When we talk to customers, a lot of folks say, going back to that part of expecting more, people say, oh, this is good, and if I start a new Python project or a Go project, it's very helpful with the scaffolding, and then I'm working on my 10-year legacy project, and it's not as helpful as I would like it to be.
I was about to ask that question. Your typical customer is for enterprise. We are not talking about individual developers here. Enterprise have years, I was about to say 10, but 20, 30, 40 years of legacy code they have in their private repository. The model we are deploying is your public model trained on public data plus the synthetic data, as you explained. So is there a way to integrate a private code base inside the model, like with a RAG or something like that?
So we in the relevancy bucket, we provide that through fine-tuning and several RAG capabilities. As I have a hard time saying RAG as a feature, because RAG to me is a non-ending set of small features that make sure that we fully utilize the growing larger context windows with the most relevant information you need for the problem at hand. And that, for example, at Poolside, will sort all your dependencies of the projects and then understand which ones are more important for the code you're writing now, so the next completion is very good. You can bring external links if you want. So all of these are aspects or fractions of RAG. But I think industry-wise, when we talk about RAG, I think we actually need to start being precise about which kind of RAG feature we're talking about. We provide that, and we provide fine-tuning. So fine-tuning...
So the model that customers are deploying inside their VPC is not your public model, the standard model. It's fine-tuned with their code base.
So we give a customer, again, everything is on VPC. The setup is pretty straightforward and automated.
I guess it's a CloudFormation template or something equivalent.
It's Terraform and Helm charts. And basically, you have a foundation model at that point. But you'll always talk to our solution architect team and our applied research team and tell us about your challenges, because this changes. For example, some companies say, oh, the technologies we work on, these are very large companies, they don't, there's not a lot of this technology out there on the open source, so nothing pretty much works. So there's the use case of using fine-tuning for large technology groups that don't exist in the open source space, and you can probably think about a few companies like that, and the others that have that 20-year-old project and just want some added relevancy, and we provide that with fine-tuning and RAG. So we do give you the base model that you could use as a base model if you're happy. If you don't, if fine-tuning is not a key requirement of yours and you just want to start with a Poolside foundation model, great. Everything will work fine. Or you can also fine-tune it. And the beauty of it is that you can use multiple models. So you could have, and this is the case a lot with either very large corporations that have siloed divisions, or government entities that have multiple small departments, and you would fine-tune different models depending on the department, and then you will segregate the access with role-based access control to say, oh, this developer only has access to this model, so there wouldn't be any code suggestions from a very secretive part. Yeah,
I was about to add that question. If you can segregate the different models,
we can, and it's something we don't even talk about that so much because
that's very important for large enterprise and and government, as you said.
And the beauty of it is that, and this is something I'm really proud that we do, because it makes us accountable. So Poolside from day one ships with everything you do that interacts with Poolside is logged. So when you ask us, how do we know, if you're a customer and says, how do you know we're actually making good use of the product? And we just say, you have the telemetry, put it on a BI tool, and check how often our JavaScript ghostwriting suggestion is being accepted on a daily basis. And then imagine that we fine-tune a model. We'll give them the base model, they use it for a month, they like it, they say they could use more relevancy, etc. Let's fine-tune a model on all of their JavaScript code, and let's give it to the same people. And let's do some A/B testing. So what was the rate of acceptance? What was the rate of reprompting, of accepting a chart suggestion and clicking the implement button? When you do click the implement button that generates the diff, how many times was that diff accepted versus rejected? And then there's other aspects which we have to work on, for example, which is showing the churn that doesn't happen through the extension, the changes, etc. And that's, again, evolving logging that we'll work on. But a lot of the times you do not have this information, and probably because the data is not there, so it's harder to obtain. It's on a database somewhere, but then you'll need an API, etc. Because we have these logs, you have total transparency on how your developers are making use, good or bad, of Poolside, and that has implications into enabling, has implications into understanding if our model needs tweaking, either through fine-tuning or any other technique to get better responses. Allows us to go and look at certain groups or projects and says, well, why does this particular group, because then you can segregate the users by the projects they use, this group has a very high
acceptance rate,
and this one has an extremely low acceptance rate, and there's no kind of visible distinction between the technologies, so why? And we can go look into that, and I'm very proud that that's kind of a day zero feature, because it makes us accountable. You can say, well, people use it, some say they like it, some say they don't like it, but what are the numbers really? So I'm very happy. Yeah, show me the data. Yeah.
It's a question that is not related to Poolside, but at the end, the C-level person that will sign the check ask about the return, and the return is often about developer productivity.
Yes.
So, in your opinion, how do you measure or see developer productivity?
On our POV includes before someone decides to buy Poolside, the execs will be shown a report based on a qualitative and quantitative analysis of developers' feedback and their use of Poolside. And this, again, it's something that makes us super accountable on delivering a good product to developers. Because if we finish the POV and say, we started with 100 users using the product, and there's 10 at the end of the month, that speaks by itself. But if there is 80, and they're using it every day, that's super powerful. And we can show examples, and we can say where the impact is.
So you're showing by data, by example, by impact, rather than trying to measure an evolution in the developer productivity, because it's super hard to measure the developer productivity.
It is very hard, and it's funny you say that, because a lot of the people that are at Poolside used to work in companies that was their only goal, end-to-end developer productivity.
By number of lines of code produced, number of issue closed,
end-to-end, code,
code,
the version control, the deployment, etc. And that continues to be extremely hard to measure. As an engineer, I would love to have that as a founding thing in any company I would create. Try to really understand how long the churn, where are the bottlenecks, etc. So Poolside at this point has control over that data. So to actually measure from an idea to deployment, there's probably something where AI can help with that. And our goal with Poolside is, especially through the API, that we code assistance. Let's just be honest. This is where we have to compete today because of the model capability. It was never even an intermediate goal. Obviously, we want to be AI for developers, but in an enterprise, that will likely be a software intelligence layer, the way we see it, powered by the models that you contact via the API and interact over your software development lifecycle, right? So something that can tell me if I have 5 duplicate Jira issues. Poolside should be doing that. So I can't say, because that's so long in the future, that how would AI be able to tell you, literally, if you ask it, saying, explain me what are the bottlenecks in my software development lifecycle. If it has gotten control of all the data from A to production, could help with that, but we're probably talking a few years for models to be able to capture that.
A few weeks ago, I was talking with a developer from a finance company, a bank. It was at an AWS meetup, a local branch of a meetup. And like many developers in the bank, they're working with COBOL or this type of old, quote, programming language. And the guy was telling me, these tools are great, but it's only for a minority of the developer within the bank, the ones that are developing in Java and TypeScript and these modern, again, quote, programming language. Is your system through fine-tunings can also integrate like older code repo? The challenge is that there is no public data or not too much public data about COBOL.
There isn't a lot, because I have a demo of a COBOL with Poolside, where I kind of obfuscate a tic-tac-toe file and ask Poolside what does this do. And then it identifies that it's a tic-tac-toe game. And then I ask it to change it to only win on diagonals. And it actually suggests the changes. But there isn't a lot of COBOL out there. So this is where fine-tune, it's that other use case that I said. COBOL is not even the worst one, because there are languages there that have no presence on the internet. And that's something where we see definitely our ideal customer profile. With languages that are not widely supported, where fine-tuning can bring a lot to the table. Because a lot of the times you get more relevancy through RAG than fine-tuning, depending on which technology we're talking about. Every case is different. So that's definitely where our playground is at this point, to bring that added relevancy.
Can we use Poolside.ai as well to transform code, to migrate code? Like I want to migrate my old legacy COBOL to Java.
No.
Not yet.
And our co-founders are very particular, especially with that answer, because there's way, oh, maybe you can try, and we don't think there's any model out there that can do that through AI alone. I've seen some demos where you can do it through some traditional coding with AI assistant. But my issue, and this is not just the co-founders, but my personal issue with this is that as an engineer, I have two options. I either do it myself and I have AI helping me, which I think is where we are today.
Mm-hmm. Yep.
Because if I click a button here, let's imagine I have here a button that says JavaScript to Python, and I click it, and now I'm looking at my laptop. Or I don't need to look at like we can make this agentic, but I'm waiting for the output. Half an hour later, I get the output. I try to run it. It doesn't work.
It's not working.
So I click it again. And it doesn't work again,
Mm-hmm.
right? I was talking to this with our co-founder, Iso, and I was saying, thinking if our new next state-of-the-art model would be able to do this. And he says it will, but it will need to have a very high success rate for every small task. It needs to be like 4 nines, because a single mistake in the chain of migrating a whole project from one technology to the other will invalidate the migration. And obviously there's reasoning, there's validation at the end. There's a lot of things you can bolt on. You can train the model to not just do conversion, but testing, do it again. But again, that today, even with the state-of-the-art models out there, it would probably take hours and hours and hours. And for large projects, I don't think any model would be able to do it today. I would be happy if someone can prove me wrong. But we're very, we try to be very clear-cut in some of these capabilities that people are wishing for, and everyone asks us that question. Like in every meeting, that question comes every single time. There's one and another one that we haven't talked about yet.
You will tell me.
But and our co-founders, if they're me, says no, we don't want to sell you something that's completely realistic at this point. Don't worry. As soon as we have a prototype of it working, where we say this just works now, this is kind of the baseline of what our model can do, you'll be the first one to know. But it's something we're very precise in saying, no, you have to wait a bit longer.
And so what is the other question you receive at all?
The other question is so we haven't talked about this, but the other aspect that, because all that information when you're interacting with the model gets logged, right? We can use that information to do reinforcement learning through human feedback.
See if suggestion was accepted or not. Yeah. That's reinforcement learning.
And we can do that. It's not automatic though, because we understand how companies, we park that and we can do a batch job later. And everyone says the same thing, which is, no, but I don't want to use all of that data. No, it's their data because it never goes anywhere, but they're worried about who's reinforcing the model. It's like, I have people that I know every line of code they write, I could print it in a book, and other people that are just starting, right? Or just migrate the technology. As an engineer, I know if you put me in a Go program, I'm not sure what I'm doing.
Yeah, and then sometimes as a developer, I accept a change and suggestions, and then I say, no, it's not good, and I change it after. So
that's the question everyone asks is, how do, it's on the fine tuning, it's always, but I have very bad code. How do I filter the bad code and only reinforce with the good code?
Yeah.
And then I have a lot of developers. I'll only want to reinforce them all with 15% of the developers. And we're working on that, on all aspects of filtering. And also on the fine-tuning, going through the commit history and apply a lot of different filters is something that we also have to work on. I just had a customer this week asking, can we filter the commit history through a group of individuals and only fine-tune on that group of individuals, which I said, not now, but I don't see that as being very hard because the algorithm is just selecting the data and it's just an if condition. So we will have to continuously work on that. But it's an interesting question because when you're trying to fine-tune on large code bases, the question is like, do you want relevancy or do you want And we know that fine-tuning, for most of the experiments, they basically generalize a lot, best practices, conventions. They can give you some precision, but that's where RAG comes in as the precision feature for relevancy. The good thing is that when you start a POV or start using Poolside, you could do those experiments as well. You could say, I know, if a customer could say, I know for sure that if we fine tune on this data set, it's going to perform better than this data set. And I can say, okay, then do both and tell me the results afterwards.
And do an A/B testing on the two.
Which has its own issues because of the control groups, etc. But the fact that that's possible to do, as an engineer, I love the concept of by data showing that A better than B or vice versa.
Again, show me the data.
Yeah.
So you're selling to enterprise. You said if I want to get started, if our listeners are convinced, is it self-service or they need to contact your sales team?
They just go to Poolside.ai, fill a form, and we'll get back to them. Our team is all here at reInvent. Obviously, this is being broadcasted after. But I like to think we're a super friendly group of people that can talk to you and your enterprise, and if it fits, we'll definitely put our best foot forward, and if it doesn't fit, we'll say, hey, there's probably a better solution out there for your current use cases. So we're very pragmatic like that. I think you'll enjoy talking to us.
Vitor Monteiro, your heads of solution engineering EMEA. We were talking about Poolside.ai, next generation coding assistant, if I want to summarize it with four words. Thank you for having listened to this podcast episode until the end. See you next week for another episode. But now, go build.